In this lesson, I'll provide a high-level look at the Objective-C language and a bit of its history and key features. The language was first created in 1983 by Brad Cox and Tom Love. They really liked the features they saw in the Smalltalk language, specifically its ability to create these reusable components that could be written once and then reused in a large number of scenarios. But they needed better compatibility with the C language. So they went about creating the C-based language that could provide this functionality. Now, Objective-C was licensed by Next, the company that Steve Jobs had started after leaving Apple in the mid-1980s, and it was used to build the AppKit and Foundation frameworks which formed the foundation of the Next Step OS. Apple then acquired Next in 1996, taking ownership of the Next Step OS, and this was used as the basis for OS X. Today, Objective-C is the foundation of the Cocoa APIs found in both OS X and iOS. Now, Objective-C's ascent is really quite interesting. Up until a few years ago, unless you were a Mac developer or somehow plugged into the Mac development scene, it's entirely possible that you'd never even heard of the language. But thanks to the incredible popularity of the iOS platform, Objective-C is now one of the most popular languages in the world. According to the most recent TIOBE Programming Community Index, which ranks the popularity of a variety of programming languages, Objective-C is now ranked number 4, only behind C, Java, and C++. Pretty amazing. Objective-C is built entirely on top of standard ANSI C. As such, it's considered a strict superset of C. This means that any valid C code is also valid Objective-C code, and you're free to mix and match these as necessary, and in fact often do. But of course, Objective-C is an object-oriented language, whereas ANSI C is not. So there are a number of extensions that were added to support object orientation, as well as additional syntax and types to support the full suite of features you'd expect from an object-oriented language. Objective-C is considered a dynamic object-oriented language. So what does this mean? This dynamism comes in 3 forms. There's dynamic typing, and this allows your application to determine the class of an object at runtime. You'll sometimes hear the term duck typing, which comes from the phrase, if it walks like a duck and it talks like a duck, it must be a duck. This simply means that we can think less about concrete types and more about object features and behavior. It also supports dynamic binding. With dynamic binding, method resolution is deferred until runtime. This is opposed to static binding used in languages like Java. In Java, for instance, if the compiler can't resolve a method at the time you compile, the compilation simply fails. In Objective-C, the resolution doesn't happen until a method is actually invoked, and this simply provides flexibility to intercept, change, or possibly redirect a particular method call. And as your experience with Objective-C grows, you can take advantage of these features in your own code, and certainly Apple's frameworks make heavy use of these features. It also supports dynamic loading, and this allows modules of code to be loaded on an on-demand manner. So instead of loading all of your code or resources at launch time, we can defer loading of these assets until they're actually needed, and this can greatly enhance performance in your application. You now have a high-level understanding of the history and key features of the Objective-C language. In upcoming lessons, we'll dive into the details and begin writing our own Objective-C code.